Hi everyone, in today's video, I will explain some of the question of the topic vector spaces, and this question was asked in Purvanchal University 2022, and the question is examine the linear dependence and find the relation if dependence. So these are the four vectors, so we have to first examine the relation between them, if there is relation between them or not, and second we have to find the relation if it is dependent. Let lambda1, lambda2, lambda3 and lambda4 be any four scalars. To convert this vector into equation, we defined lambda1, lambda2, lambda3, lambda4, which are the scalars. So now we multiply this lambda1 into b1 plus lambda2 b2 plus lambda3 b3 plus lambda4 b4 equals 0, and let it be equation A. And lambda1 b1 is 1 to 4, lambda2 b2 is 2 minus 1 3, lambda3 b3 is 0 1 2, and lambda4 b4 is minus 3 7 2, and which is equal to 0. Now first of all, taking this first lambda1 and 2 lambda2, and lambda3 is here 0, so and minus 3 lambda4 equals 0. Then this second 2 lambda1 minus lambda2 plus lambda3 plus 7 lambda4 equals 0, and then third one 4 lambda1 3 lambda2 2 lambda3 and 2 lambda4 equals 0. Now arranging in the matrix form, the coefficient of lambda1, lambda2, lambda3 and lambda4 are 1, 2. Here the coefficient of lambda3 is 0, minus 3. Coefficient of lambda1 is 2. Coefficient of lambda2 is minus 1, 1, 7, 4, 3, 2, 2, and this lambda1, lambda2, lambda3, lambda4 here, and this 0 0 0. You should keep in mind that by changing in matrix form, this 1 to 3 will be changed into this column 1 to 4, and 2 minus 1 3 will be changed into column 2 minus 1 3, 0 1 3 changed into this column 0 1 3, and finally minus 3 7 2. This vector changes into, and this one, that is minus 3 7 2. If it is not like this, then there is a mistake in this part. So let this be a matrix, this be lambda and this be b. So a times lambda equals b. Now the augmented matrix C is A and B, the combination of A matrix and B, that is 1, it is 1 2 4, 2 minus 1 3, 0 1 2, and minus 3 7 2, and 0 0 0. Now we need to change it into upper triangular matrix. Upper triangular matrix means here there should be 0 0 0 0 and 0 here, because here is one more column than rows, so here should be also 0. So we try to make 0 in this place. So to make here 0, we apply this in R2, R2 minus 2 R1, that is 2 minus 2 0. So here also this minus 2 times 2 minus 5 1, and 7 minus 2 times minus 3 is 13 0. Similarly, to make 0 here in R3, R3 minus 4 R1, that is 4 minus 4 is 0, Similarly, minus 5 to 14 and 0. Now from here it is here and here already 0, so we need to make 0 here, so we just subtract in this r3 minus r2, in r3 minus r2, so it would be 1 2 0 minus 3 0 as it is, and 0 minus 5 1 13 0 as it is, and 0 minus 0 is 0, minus 5 minus 5 is also 0, 2 minus 1 is 1, 14 minus 13 is also 1 0, so 1 1 0, 1 1 0. We try to make 0 here, so if you try to make 0 here, then with the help of this, then this will be 0, but 1 minus 1 is 0, but this minus 0, 0 minus minus 5 is 5, so this 0 will become 5, and we cannot also make this 0 with the help of this, so we cannot make this 0 with the help of r1 and r2, so leave it as it is. Consider this a lambda equals b, this 1 2 0 minus 3 0 minus 5 1 14 0 0 1 1, and here it is lambda 1 lambda 2 lambda 3 lambda 4 equals this 0 0 0 0, and now it would be uh, this will be lambda 1 lambda 2 lambda 3 and lambda 4, so lambda 1 plus 2 lambda 2 minus 3 lambda 4 equals 0, and 5 lambda 2 plus lambda 3 plus 13 lambda 4 equals 0, and lambda 3 plus lambda 4 equals 0, and let lambda 3 be key. You can also leave it as lambda 3 or substitute any value k. If lambda 3 is k, then lambda 4 is minus k. This k is non-zero constant. It may be anything 1 2 3 4, but non-zero means it can be 0. And from equation 2 it is minus 5 lambda 2 plus lambda 3. Lambda 3 is k, and plus 13 lambda 4 plus 13 lambda 4 is minus k, so equals 0. We need the value of lambda 2, so it would be this k minus 13k minus 12k minus 12k, and this minus 5 lambda 2 becomes 5 lambda 2, so lambda 2 equals minus 12 by 5k, and from equation first we get this lambda 1 plus 2 times this is lambda 2, 2 times lambda 2 is minus 12 k by 5, and minus 3 lambda 4 is minus k equals 0, so it would be taking it to this side, lambda 1 equals taking minus to the right side, it will be plus, so 12 to the 24 k by 5, and nice minus plus, and plus will be minus here, minus 3k, and taking 5 LCM, it will be 24 minus 5 is 15, 20, 24 minus 15 is 9, so it is 9k by 5, 9k by 5. Since lambda 1, lambda 2, lambda 3 and lambda 4, these all are non-zero, so therefore the given vectors are linearly dependent. I repeat this, I bolded this non-zero and linearly dependent. If anyone is 0, then it will be independent. Here all are non-zero, so it is linearly dependent. Now examine the linear dependence. This is done. Now find the relation if dependent. By this, it is dependent, but what is the relation between them? To find the relation between them, with this equation, lambda 1 b1 plus lambda 2 b2 plus lambda 3 b3 plus lambda 4 b4 equals 0. So lambda 1 is 9k by 5 b1 minus lambda 2 is minus 12k by 5 b2 plus lambda 3 is k b3 and plus plus this minus k into b4. So taking k common and taking it to right hand side, it will be 0 by k is 0, and again multiplying both side by 5 in right hand side, it is 0 times 5 is 0, so here it will be 9k. K I have already thrown here, so it is 9b1 minus 12b2 plus multiplying by 5, it is 5b3 minus 5b4 equals 0, and this is the required equation. So this was in this video, and in next video I will solve the question of matrix of transformation that was asked in 2021 in Purvanchal University. And till then, goodbye, take care.